Okay, today we're going to talk about special angles. So let's start out with a review. Now, instead of putting like with sine opposite over hypotenuse, which that's what sine is, but I want to put it in terms of like x, y, and r that we talked about last week. Because with our, if you look kind of down at the notes, we're talking about an axis, so we want to talk about x and y. It'll make it a little bit easier later. So if we're talking about a triangle, and here's my angle, my y value would be up and down, x would be across, and my r is my hypotenuse. My sine would be opposite over hypotenuse, so it would be y over r. Cosecant is going to be that flipped, so r over y. Cosine is adjacent over hypotenuse, so x over r. And tangent is going to be opposite over opposite over adjacent, so y over x. Okay, so that's just a little review. The next part, we're calling this a unit circle, which means our radius is 1 unit. Okay, so if my radius is 1 unit, then this point would have an x value of +1, and my y value at this point would be 0. So that's what we're going to do for this unit circle. So for this point, my x would be 0 and my y would be +1. If I keep going counterclockwise, my x would be -1 and my y is 0. And x is 0, y is -1. Okay, so you know that circle we drew with all the angles and the radians? Yeah, we're going to add to it, and we're going to put what sine and cosine equal in this unit circle. Okay, we're talking about just 1 unit whenever we fill out the whole thing. And I think we'll fill the whole thing out tomorrow. Yeah, I'll do that tomorrow. But this is kind of where we're headed. Okay, so this is saying like when my angle is 0. 0 or 360 degrees. There we go. My x is 1 and my y is 0. Now, if I were to draw a triangle here, okay, we know we have 1 and my y is 0, right? And I know that wouldn't make a triangle, but let's just say we have a triangle like this, okay? And we want to figure out what r is. That way we can figure out sine, cosine, and their reciprocals. So let's just say we have 1 and 0. To figure out our hypotenuse, you would have to do a squared plus b squared equals c squared, right? So we would get 1 plus 0 equals c squared. So c squared would equal 1. And if you take the square root of that, you would get plus or minus 1. Right. Now your hypotenuse is always positive. So our r would equal 1. Okay. Now this happens for each point that you see. Your r is going to be 1. And the reason is, like, even if I take this point where I have an x that's -1, and I make this triangle that really isn't a triangle, you have -1 and 0. If I square that side, I would still get a +1 like I got here. Okay, so no matter what point you're at, you're going to have a hypotenuse of +1 for a unit circle. Okay, so just something to remember. I just want to explain how we got that. Okay, so let's fill in our tables. Let's do sine of 90 degrees. So 90 degrees is this one that goes straight up here. That would be 90 degrees. Okay, and our sine is y over r. Right? So we're going to take our y value divided by our hypotenuse, which is 1. Okay, so look at that point. Our y value is 1. So 1 divided by 1 would be 1. 180 degrees, our y value is 0. So 0 divided by 1 is 0. 270, -1 divided by 1 is -1. 0, 360, 0 divided by 1 is 0. Okay, so anytime you have the sine of 90 degrees, it's going to be 1. 180, 0, and so on. Okay, cosine of 90 degrees. So we're doing x over r, so 0 over 1. So 0 divided by 1 is 0. 180, our x is -1, so -1 divided by 1 is -1. 270, 0 divided by 1 is 0. And 360, our x is +1, so 1 divided by 1 is 1. Okay, tangent is y divided by x. Okay, so look at 90 degrees. We're going to take y divided by x. So 1 divided by 0. And you can't divide by 0, so it's undefined. You actually have a vertical asymptote there, and you'll see that later on when we graph these. I don't know if it's next, like the week after spring break or the week after, but we'll graph trig functions later. 180 degrees, we have 0 divided by -1, 0 divided by anything is 0. 270, -1 divided by 0 is undefined, so we have another, we have another asymptote, and then 0 and 360 would be 0 divided by 1, which is 0. Okay, so that's our tables. And then the two questions at the bottom, what would cotangent of 90 degrees equal? Okay, so look at you can look at the tangent table, or you can look at the graph that we made. So if you look at this graph, we're talking about 90 degrees. So go to 90 degrees, and instead of being y over x, cotangent is x over y. So 0 divided by 1 is 0. And you could just flip your tangent. Instead of it being undefined, where you're dividing by 0, if you flip it, now the 0 is on top. All right, cotangent of 180 degrees. So if we flip that tangent, that 0 is going to be on bottom now, and you can't divide by 0, so it's undefined. So if you know sine, cosine, and tangent at these 90 degree marks, you can find cosecant, secant, cotangent, all the other functions. Okay, now that we've done all the 90 degree angles, now we're going to do all the angles in between. So that's how we talked about special triangles yesterday. So we could use the 30 degrees, 60, and 45 to make up our whole circle. Okay, so at the top, we're going to label the sides like we did yesterday. So opposite of that 30-degree mark, that's going to be your x. Your hypotenuse is 2x, and then across from the 60 degrees is x squared to 3. Okay, so go ahead and label your triangles. And then the 45, 45, 90, that's an isosceles triangle, so the sides are equal, and our hypotenuse is x squared to 2. So that's what we did yesterday. Now the next part, it says let x equal 1. So we are going to label these triangles again, except instead of x, we're going to use 1. So this will be on the right side of your notes. Okay, so let's see. Instead of x, it would be 1 across from the 30 degrees. Sorry, y'all's has the 30-degree one first. So it would be 1, 2, square root of 3. And then for the 60-degree one, across from that 30 degrees is going to be your shortest side. So 1, 2, square root of 3. 45 degrees, be 1, 1, square root of 2. Okay, so now we're going to find our sine function for 30 degrees, 45 degrees, and 60 degrees. So sine of 30 degrees, and you can look at whatever triangle you want, but your sine is going to be the opposite over hypotenuse, right? So opposite of the 30 degrees would be 1, no matter what triangle you're looking at, right? So it'd be 1 over our hypotenuse, which is 2. Okay, on the 45-degree angle, we're doing an opposite over hypotenuse, so 1 over the square root of 2. And let's go ahead and simplify that radical. So you would multiply by the square root of 2 to get rid of the radical in the denominator. And what you do to the bottom, you have to do to the top. So it'd actually be the square root of 2 over 2. 60 degrees, I'm going to look at my 60-degree angle, doesn't matter what triangle. So across from the 60, we want the opposite, so square root of 3 over 2. Okay, and then we're going to do cosine. So cosine of 30 degrees is going to be, cosine is adjacent over hypotenuse. So the side adjacent to the 30 degrees would be the square root of 3. We want the side right next to that angle. Here, 30 degrees, the side next to that angle would be the square root of 3. Over the hypotenuse, which is 2. Okay, 45 degrees is going to be adjacent over hypotenuse, so 1 over the square root of 2, which whenever we simplified it, we got the square root of 2 over 2. You don't have to do it again. 60 degrees, we have adjacent over hypotenuse, so 1 over 2. All right, the last part